Hi guys, Mrs. Kohler here. We're going to go over solving equations that either have no solutions or infinitely many solutions. So for the first example, we're going to start out the same way every time. Line down the middle. All right, on the left side, we have some distributive property that needs to be done. So this 3 on the outside of the parentheses is going to be multiplied times 2x, which will give us 6x. And then we have 3 times that positive 5 on the inside, which will give us a positive 15. All right. And then on the left side, there's no distributive property, so we can just bring that down and keep it the same way it is, 6x minus 7. Now, previously, when we've had variables on both sides, I've explained to you that you need to get rid of the smaller amount of variables. In this case, they're the same, so let's see what happens when we get rid of them. If I subtract 6x from both sides, it'll cancel out on the left side, leaving us with 15. And on the right side, it cancels out, leaving us with negative 7. All right? 15 does not equal negative 7. It never has, it never will. Okay? This is a false statement. Because you've ended up with a false statement, that means that the answer is no solution. There is no value of x that will make this equation true. All right? So, in example 2, same thing as previous videos. If you want to write this down and pause it so that you can work it out yourself and then check your answer, you can do that. When we work this out, the distributive property is on the right side. Now, there's not always distributive property, but I thought it would be a good thing to throw in just to refresh your memory. So if I do 5 times 2x, that gives me 10x. And then if I do 5 times 1, that gives me a positive 5. All right. On the left side, we can go ahead and bring that down the way it is. So 10x plus 3. All right. Now, we have 10x's on both sides. Let's go ahead and eliminate those and see what happens. So I'm going to subtract 10x here. Cancels out on the left side, leaving us with 3. And on the right side, it cancels out, leaving us with 5. All right, again, 3 does not equal 5, never has, never will. This is a false statement, so the answer to this problem is no solution. All right, moving on to example 3. This one is a little bit different. Same thing as always, though. We're going to split down the equal sign. There we go. All right, on the left side, I'm going to do 2 times 4x to get 8x, and then 2 times 3, which gives us a positive 6. On the right side, there's no distributive property, so we can go ahead and write that the same way it's shown, 8x plus 6. And just like the last two examples, we have the same amount of variables on the left side as on the right side. So getting rid of the smaller amount means getting rid of both of them. So when we do that, we're going to subtract 8x from both sides. So on the left side, the 8x's cancel, leaving us with 6. And the 8x's on the right side cancel, also leaving us with 6. Now, because 6 equals 6 is a true statement, that means that we have infinitely many solutions. Meaning any value of x that's plugged in will cause this equation to be true. All right, so this is an example of infinitely many solutions for example 3. Now, moving on to example 4. Again, if you want to pause the video, write down the question, write it out, and then check your answer with us, you're more than welcome to. So we're going to start off by drawing our line down the equal sign. All right. I'm going to go ahead and distribute that 3 on the left side to give us 9x and a positive 15. Remember, when you distribute, that's multiplication. And then on the right side, you have 9x plus 15 as well. All right, right off the bat, you can probably tell that both sides match, but we're going to go ahead and work through this anyway. If I subtract 9x's from both sides, then it'll cancel on the left side, leaving us with 15. And the 9x's cancel on the right side, also leaving us with 15. Again, 15 equals 15 is a true statement, which means that our final answer would be infinitely many solutions. So any value of x will work to make this equation true. I hope this helped. If it didn't, you can ask me more questions in class or send me an email.